a quick discussion on what is referred to as significant figures. So, when there are measurements available of physical quantities, then in a given measurement, the number of digits in which we have confidence, that measures what's called the number of significant figures. Let me give you examples and rules, plain and simple. So, the first rule is all non-zero digits are significant. All non-zero digits are significant in a number. So, let's look at these examples. These are outcomes of measurement of different physical quantities. 3126, all non-zero. So, how many significant figures here? 4. 4.57, how many significant figures here? 3. 11.681, 5. These are all non-zero digits and they constitute part of number of significant figures of this. Now, let's look at the second rule. 0 is significant if it appears between two non-zero digits. So, even if there is a 0 featuring in the measurement, then it will make sense if it is flanked by non-zero digits. If it's flanked on either side by non-zero digits, then that 0 is going to be counted. So 6.203, it has a 0, but on either side of the 0, you realize that there are non-zero digits, 2 on the left and 3 on the right. So 0 is going to be counted as a significant figure here. So the number of significant figures here would be inclusion of 0, 1, 2, 3, 4. Look at this 5.01. There is a 0 here, but on either side of the 0 there are non-zero numbers and therefore 0 would be counted in. So the number of significant figures here is going to be 3. That's rule 2. Then look at rule 3. The zeros occurring to the left of the last non-zero digit are not significant. The zeros occurring to the left of the last non-zero digit, are not significant. What does that mean? Look at this, 0.062. Look at 0.062, right? In this case, this is the 0 occurring to the left of the last significant digit here, right? After 0, there are significant digits, but before 6, there are only zeros, and these zeros will not be counted. The zeros occurring to the left of the last non-zero digit are not significant. See? Look at these non-zero numbers, and to the left of them there is a 0. This 0 will not be counted. So 0.062, it has only 2 significant figures, 6 and 2. Look at the next one. Zeros are placed to the right of the number are significant. Zeros placed to the right of the number are significant. So, look at this, 5.180. So this 0 would be counted as a significant figure. 5.512.00. So in this case, this 0 counted and the number of significant figures are 1, 2, 3, 4. Look at 512.00. These zeros are counted and the number of significant figures would be 5 here. Look at this, 101.600. These zeros will also be counted. 101.600. These zeros will also be counted and the number of significant figures would be 6. Yes or no? 3 and 3, 6. So that's as far as rule 4 is concerned. Let's look at rule 5. In exponential notation, the numerical portion gives the number of significant figures. So let's say 5.732. Number of significant figures will be given by this 5.73. So 3 significant figures. 6.02, 3 significant figures. That's how it happens. Let's look at significant figures don't change by changing units. For example, 1800 millimeters could be written as 1.800 into 10 to the power minus 3 kilometers, right? Then if you convert units, the number of significant figures won't change. So that's a small basic understanding of significant figures, right? So in exams, they sometimes post problems on this, and if you remember these rules, if you remember all these rules, then you'll be on with the job. Thank you so much. Bye-bye.